So hi everyone, my name is Paul Koufalis. I'm here to talk to you about the poor, neglected remote client. So interestingly enough, a few years ago, I did this talk called Benchmarking Network Data Transfers, and it was really popular. I did it at a bunch of pugs around the world, and we really talked about this concept of client server and how you can optimize client server connectivity. And really, with virtualization taking over, and now you've got this hyper convergence happening, we've taken that client server level kind of to a whole other level, and application architects are requiring also now to separate the application layer from the database layer. So again, you're seeing more and more complexity, more and more issues around these network communications. So I said, you know what, it's time to do another talk, some more benchmarks about this. So who am I? I've been doing this since 1994. The fun thing is that, at White Star, our smallest client is like 10 users. Our largest client is 5,000 users, more now, 10,000 users. I lost track. So we kind of get to see everything. So it's a lot of fun for us. All right, so let's see some data. What did I do? Here in my home lab, I created two virtual Windows 10 environments. Now, the physical VMware ESXi server is sitting right here in my office. So I put two virtual machines on that VMware ESXi. I took my desktop computer and I took my laptop. So all of them are on 192.168.51.x. So we're not routing, we're not jumping over things, we're not going outside of this LAN. They're all physically connected into the same switch. So I've eliminated as much of that complexity as possible for this simplified benchmark. Why am I telling you so much about this? Because in your work environment, you're going to jump a lot of hoops, right? Your clients who are running your OpenEdge application or who are running a web browser, they will not be on the same VLAN likely as the server. And it could very well be that your PASOE or your classic app servers are on a different VLAN from your physical or your virtual database server. You might have some parts of it in, for example, in a DMZ. So there's lots of network hops going on, depending how your network is set up, depending how the architects have placed things in different VLANs. So I simplified this as much as possible, but keep that in mind when you're looking at your own environment. I also didn't play with MTU, so it's 1500 across the board. So you can look at MTU on your server side only, right? So if your app server and your database server are both kind of in the same VLAN on the network, you can consider looking at enabling jumbo frames and seeing if that improves your throughput, for example. So how do we do our benchmarks? ProTop, of course, Sports 2000 database. Important for us to give you the tools that you can repeat these tests in your own environment. There's nothing here that you can't do yourself. We're using the user experience, shared memory, local host, client server metrics in ProTop, and I show you the link. You can go look. You can go try this, in half an hour on your own environment. All right, so very, very easy to do. So what's the ProTop user experience metric? So we said, let's, again, simplify a benchmark here. It's not that it's not meant to be real world, but we're trying to create a benchmark that anybody can use on any OpenEdge database. And so what we do is we read the meta schema tables, underscore file, underscore field, underscore index, so on and so forth, that we know exist in every database. We also are pretty confident that there's going to be no disk IO, right? So those meta schema tables are going to be loaded into shared memory, and we'll be reading from shared memory. So we eliminate any disk IO issues from our benchmarking. So really, really interesting as a benchmark. And finally, what's cool about this user experience metric is I can run the exact same benchmark in shared memory I can run it in client server using -h localhost, so using the loopback driver, and I can do it in client server across the actual network. And I can compare the three graphically, and you'll see I'll show you the results here as we go through. All right, great. So how did I do my tests? Well, I told you I've got two physical computers, two virtual computers running in VMware ESXi. So I enabled the client server test, physical to physical, virtual to physical, physical to virtual, and virtual to virtual. So I said, hey, let's go test these four different things and see what kind of interesting numbers come out of them. All right, let's see. So number one, I said, hey, usually we start with the horrible stuff and then we show you better and better. No, I'm going to show you the good stuff first, and then we'll get worse and worse. All right, so we'll start with prefetch factor 100%. So we're saying, you know what? Try to fill those message buffers as much as you can, and each message is 8192 bytes, right? The OpenEdge message size. Set prefetch numrex to 64. So again, the maximum records we're saying we'll put in a message 64 records, and the maximum fill factor 100%. You're going to hit the first one. Whichever one you hit first is the one that's going to take over. So, which is why I said in the earlier slides, set prefetch numrex to 9999, for example. And prefetch priority I talked about a little earlier. So let's see what the numbers look like here. So first things first. BOGO MIPS. So BOGO MIPS is a measure of single-threaded CPU performance. And we use this so that we can compare one machine to another. And so what that's telling me here, it's telling me here that vSports and VSP2, my two ESXi boxes, are the same CPU speed, which makes sense because they're running on the same physical CPU. But my sports database, which is running on a desktop, is a little bit slower, and my laptop is a little bit faster, L for laptop sports, all right? So that's a little bit faster of a CPU. And that shows up here in this user experience shared memory. Now our expectation is that shared memory really correlates quite well with the BOGO MIPS that we have here. And you'll see that that's true as we go through the various tests. And so the two virtual machines can do both around 425,000 reads per second in shared memory. My desktop can do 300, and my laptop can do 500,000. Now, here's where it gets interesting. For a reason that I really can't explain to you right now, one virtual machine could do 200,000 reads per second in -H localhost, and the other one could do 250, right? And the number is pretty clean across the graph. You can see it. There's not that much variation. Why? I'm not really sure. I mean, there's some minor differences in the virtual machines. They're both running 12.3, so I think all of this is on 12.3. So honestly, I don't know why or how the difference is. And why am I pointing this out to you? Because these numbers are not as clean cut in every environment. We just see a lot of variation from every, one customer environment to another. So it's really important that you test these numbers in your own environment to see if you are going to be surprised. So interestingly, like I said earlier, the shared memory to BOGO MIPS it's pretty consistent, around 55 or 60, right? But the shared memory to localhost ratio, that one varies, right? From anywhere from 1.7 to 2.5 in terms of the speed. So now we're going to go to the interesting stuff, which is client server. So remember, we're doing physical to physical, physical to virtual, virtual to physical, and so on and so forth. And so here we see much bigger variation in user experience client server, right? So we can see here that my ratios they go all the way from a 1.7 to 1. So on this vSports, this ESXi box, who's being hit from the other virtual box. So you can see it says here, we're doing V2V here, virtual to virtual, and I'm only getting 120,000 reads per second across the NIC, right? Versus 200,000 reads per second that I was getting when I was doing a local host. Now, for this guy here, VSP2, I've got one of the physical laptops talking to that database and client server, and here I dropped from 250,000 to 80,000 reads per second. And then here, interestingly, again, going from a virtual machine to a physical machine, I lost about 50% down to 75. And here, wow, now this really surprised me. Going from my physical PC to my physical laptop, we dropped by a factor of 4 from 200,000 reads per second to 50,000 reads per second. Now, why? Who knows? My laptop is an HP. It's a piece of junk. I don't like it. Even if it's fast, it's an HP. So it's probably the fault of my HP laptop. I'm never going to buy an HP laptop again. Sorry if any of you work for HP, but we're going to go back to Dell as soon as this laptop does its, does its time. But interesting to see these kinds of numbers and the differences here. And in ProTop, the free version and the commercial version, you can graph all of this data. And really, in terms of the graphs that I'm showing you here, the only difference between the commercial version and the free version is how much time you have available to you, right? So in the commercial version, you can have up to, as infinite amount of time will save all the data for you, and for years and years and years in the commercial version. Whereas in the free version, we keep, I think, 48 hours of data that are visible to you. Now we have all the historical data, so if you ever convert from a free user to a paid user of ProTop, you'll get all the historical data. But in terms of using the free version of the web portal, what you'll have visible to you is 48 hours of data. But that's more than enough for you to do these benchmark tests on your environment, right? You can run the benchmark, grab a screen capture and say, all right, here we are, here I am, at this time, these are my numbers. Let me change them, restart the server, run the benchmark again for a few days and see what happens. And the other thing that's interesting about trending this data is you might see variations in the data that are not related to a change in database parameters. So what happened here? I didn't change any database parameters here. What happened? And we see this in production where there's some kind of operation that occurs at some point in time that affects the network performance. Or we've been at customers where we've seen this number degrade over time. So nothing has changed in terms of the database. So BOGO MIPS is constant, user experience shared memory is constant, user experience localhost is constant, but our performance across the network interface card is dropping, and invariably it leads to some infrastructure problem unrelated to OpenEdge, but you're sharing your network with so many other components. Again, especially in a virtualized hyper-converged environment, there's more complexity, more shared, more layers of resources that are adding complexity and adding potential for problems to your environment. So having this historical view so that you can go back to your infrastructure team and say, what happened on Sunday at 2:46 p.m. because my performance went to crap exactly at that point in time. And we all know what the answer is. The answer is nothing. We didn't do anything. And then the second answer is, well, we made a change to this thing, but it has nothing to do with OpenEdge. And then the third answer is, when we changed this thing, it might have done, and then next thing you know, sure, that's the problem. But having this trend data visible to you really makes it easy to go back to the infrastructure people and say, we know you made a change at this time. Go through your change requests, go through your changes, tell me what changed, even if you don't think it's related. And you'll get a much more serious response if you've got a graph versus if you're just talking to the guy and he's like, get out of here, DBA, I don't care about you. We didn't do anything to your infrastructure. I checked, everything is fine. That's the other classic thing we get. I checked, everything is fine. Performance is great. So really good to grab these. And again, even with the free version, just screen capture these every now and then so you have some history of your network performance. Okay, so let's talk about a couple of things that happened here. So BOGO MIPS, we said, was pretty consistent. That was cool. All right. And we were looking at all of our customers, right? ProTop is running on, I don't know how many thousands of databases literally around the world. So we have data from thousands of databases, hundreds of servers around the world. And there's a project to actually try to correlate all this data, bring it all together and see if we can see some interesting trends in the data across Windows and Linux and version 9 and version 10 and version 11 and version 12, AIX, everything that's going on. So hopefully we'll have time to make a blog post about that over the next few months. I mentioned that VSP2 and vSports, identical VMs, same physical frame, but they had significantly different localhost numbers. I don't know why. And the lesson here I want to really highlight is your mileage will vary. So please test in your environment, right? Test. If you're making changes, test. If you're migrating to a new hyper-converged or a new VMware farm, if you're doing anything, if you're putting in a new switch in your environment, test before, test after, so you have the data. So it happens so often that we get the phone call after, but it's too late. I don't have the data before. So we're kind of guessing how it might have been before, and this is how it is now. So having the data across significant infrastructure changes will really help you quickly diagnose these performance problems, and especially when you're putting new hardware or new infrastructure into place, it can really help you prevent putting production onto a problematic configuration. And again, we see this all the time. So let's do test number 2. So we said, all right, hey, you know what? I want to jam as much stuff as possible here. So I'm going to increase my numrex from 64 to 9999. That's what I told you earlier was my basic number. Use this all the time, and I'm going to increase my message buffer size from 8K to the maximum supported value of 32,000. Right? So what could go wrong? More records, fill the buffers, bigger messages. Let's go faster. But of course, if I'm showing you this, it's because it wasn't faster. So what was surprising here? So BOGO MIPS and user experience shared memory, those numbers didn't change. We didn't really change any parameters in the database, only network parameters. What changed that was surprising was that my user experience localhost numbers changed. So I'm not even going out on the network, I'm staying within that loopback driver, and I still lost significant performance in my localhost. And why did that happen, right? So interestingly, we can theorize. I think the reason why these numbers are showing up like this is because the meta schema tables, there's just not a lot of records in there, and they're not very large records to begin with. So now we said, you know what, fill this very large message and send it across the network, but there simply aren't enough records in the meta schema tables to fill this 32,000 byte message. So I think we're just sending a lot of hot air across the network here. So that would be my theory. And the way to test this would be to repeat these tests with a large table with a lot of records, and then to see if the numbers stay flat or maybe even improve, right? So again, the message is always the same. Test this in your environment, because here are surprising results, that we weren't expecting, and we need to do the postmortem and say, well, why do we have these results? Okay, in this case, I'm theorizing that it's my benchmark that's the issue, but you might find that there's really an infrastructure problem that you need to deal with. And then when I look at client server, you can see the numbers really didn't change all that much in terms of client server. And that's also interesting. So how come when I do the same benchmark with minus MM32,000 in localhost, I lost performance, but across the network, I didn't lose performance, right? And again, I don't know what the answer to that question is, but interesting to have the data so that I can tweak my parameters to optimize the data. And again, you want to run this in your real world application potentially, but the benchmarks in ProTop are really to give you a nice, fair, measured understanding of your particular environment. Number 3, so if anybody's still running 10.2b08 or 11.x without the prefetch parameters, these are the default values, right? So prefetch factor here, 0. So don't fill the record. Prefetch numrex, 16 records. So the most records you're going to get is 16. And the message buffer size is 1024, and the numbers are not going to be pretty. I told you, right? So user experience localhost, look at that. We dropped user experience localhost by a factor of 2 or 3 almost in all cases. Now, interestingly, my physical sports and L sports didn't drop all that much. all right? But my network one vSport, sorry, my virtual one dropped a lot. And then, sorry, that dash on VSP2 is simply because, I don't know, something happened with my benchmarking and I don't have data. So we're going to rely on vSports for this particular benchmark, all right? And then looking at the client server, it gets even uglier here, right? So look at this. I mean, in client server mode, I went from 120 to 105 to 40,000 records per second on my virtual machine. And interestingly, on my physical machines here, so this is from virtual to physical, I went from 75 to 20,000 records. It's like a 4-time drop here in performance going from a virtual layer to a physical layer. And again, crazy interesting here, in my physical to physical layer, from the laptop to the desktop, I went from 50,000 to 8,000, right? So that's a 6 times drop in performance. And so again, I stress to you guys, you need to test in your environment here. That's the most important thing. You have virtual to virtual, you have virtual to physical, you have all of these different things in your environment. You need to test so that you understand the numbers before you migrate to new hardware, before you make an infrastructure change, before you make a parameter change to a database that might affect some of these numbers. So keep these in mind. Use the user experience, SHM, LH, and CS metrics in ProTop. They'll give you the graphs, they'll give you the numbers so that you can do these tests easily, quickly, painlessly in your own environment. All right. So graphically, this is what it looks like across the 3 benchmarks. So you can see here, it's pretty cool. So you can see right away this darker line here, we drop here, bang, for user experience client server, and the other one above it is localhost. And the ones up here, those are the BOGO MIPS and the user experience shared memory lines, which don't change. Now, they are noisy, of course, because from one sample to another, there's quite a bit of variation. So if you were to zoom in on an hour, you would see like massive jags in the data. So always better to look at a longer time frame so that some of these jagged edges get smoothed out, all right? So this is vSports, the virtual machine. And then here's my laptop, LSport. So you can see here again, my user experience client server dropped from around 50,000 down to around 8,000 reads per second. So that's pretty crazy. This little jump here, just in case you're curious, I didn't really talk about it, but when I noticed this jump here, when I went from minus MM8192 to minus MM32,000, I said, let me just try it with minus MM16,000, and bang, I came all the way back up here. So you can see it's really telling. This is minus MM8192, minus MM32,000, and minus MM16,000. So you can see the difference here in performance, in client server performance, based on the message buffer size. All right, and then the physical sports database, again, on my desktop computer, same thing. You can see the stair stepping going down as we changed from test 1 to test 2 to test 3 parameters. So how do you do this in your office? Easy. Go download ProTop from protopeurope.com, install it on your server. The instructions are right there. There's a couple of tricky points for the client server, especially on Windows. So ping us, ping James Palmer or ping me or Tom to walk you through it. We tried to document it as well as we can, but again, you might have some questions. And then you can view the results in ProTop real time. That's what Tom showed you earlier in the local character UI, or you can view it on the ProTop web portal at protopeurope.com.